Again, good morning, good afternoon, good evening, depending on your time zones. My name is Navin Sharma. I'm the head of product here at Stardog, and I'm excited to be here to present a topic that is top of mind for lots of folks that are, at least at this stage, contemplating their next journey with respect to their data platforms, with respect to their AI platforms. And certainly the topic at hand is all about future-proofing your data and AI platforms with a knowledge graph. So we'll get started here on the topic at hand. So first of all, why do we care about this topic? We firmly believe that winners in every industry will be those companies that frankly empower their knowledge workers with data and AI. I truly believe that, and this is a mission for Stardog, and I imagine this is a mission for every enterprise company out there, given the stage we are with the advent of Gen AI, a mission that is near and dear to a lot of you folks, certainly given the fact that you are actually here on this call. So when we talk about knowledge workers, and we talk about empowering those knowledge workers, it's really important to understand who these people are, and why should we care, or why should anyone care? Ultimately, these are the people that have to make important mission-critical decisions about the business and the business operations. And so it's important to understand who these individuals are. It's important to understand how they want to use data to make everyday decisions. So let's dive into some of those examples. We talk about knowledge workers in the context of supply chain. These could be supply chain analysts. These could be factory floor analysts. These could be quality control analysts. You can imagine a situation, whether you work for a manufacturer that's building cars or a manufacturer that's building drugs. There's always a scenario where you have to contemplate and understand an implication of a specific event, a quality event that may have occurred out there in the market. In this scenario, you may be given a notice about a quality note related to a fender burn for a specific vehicle that has to trigger a stop shipment in the factory. Now, as an analyst, your job is to understand if this is a one-off event. Are there other related quality notes for this particular vehicle? Was there a resolution for the quality note that was logged? What materials potentially make up the impacted component? Are those impacted materials being shipped by one supplier or multiple suppliers? And what orders are already in transition, where you have to potentially decide whether to stop shipment on those orders? And so you can imagine with each one of these questions, you are likely to find that the underlying data that you need to make those decisions does not live in one place. It probably lives in a multitude of sources of information. Now, I do believe that there is in a scenario where you want to have this information on the ready. There's a lot of work that needs to go behind the scenes to make this information readily available. But what you're also noticing is that when I think about these scenarios, I think about this in the context of exploratory analysis, questions I want to ask of my data, and be able to get an answer. You look at a scenario where now I'm a scientist or a researcher, and my role right now is to identify specific drugs and those interactions that help me understand if those drugs could be repurposed for perhaps curing other diseases. And in that study, I want to understand in the relationship in this scenario between oxytocin and autism, and if there are new opportunities for a new drug. And I may want to ask questions like, are there genetic conditions that are suitable to be treated for autism? Now, I may want to reference research papers out there. I want to understand what compounds have been tested in similar conditions with similar treatments, maybe looking at some preclinical, clinical data. Maybe I want to understand gene expression and how that might be used as a biomarker to understand whether a drug is delivering a desired effect. Which manufacturers are supplying the raw ingredients and what other studies might be relevant. And again, these are questions that are being framed as a researcher, as a scientist. In this scenario, I'm a knowledge worker in the life sciences and pharma, and I want to express my desire to ask those questions in much the same way I'm presenting here on the screen. Now, I could also be someone in the crimes division of a particular bank. I might be in the security and compliance areas. I might be an agent that's responsible for investigating crimes, financial crimes. I'm looking at potentially board members for companies where they are working and other companies that might be under investigation. So for me, as a knowledge worker, I just want to be able to ask questions. Is there an affiliation to individuals that are under investigation for other crimes? What's their financial investment stake in the company? Where are these companies located? What transactions have been associated with those individuals? Are there subsidiaries of those companies and their affiliations? And so being able to track down and do the sort of exploratory analysis may not be as easy as it sounds, because a lot of the underlying data perhaps does not, and most likely is likely not somewhere that lives in one specific area. So you can certainly understand that for a knowledge worker to feel empowered to make those important decisions that drive critical insights, prevent potential risk exposure, present opportunities to drive new revenue streams, is a very important task at hand for the data and the AI community inside of an organization, in order to fulfill and empower these folks. So what does this all lead us to? Really, the underlying problem, right? So we have lived this, we continue to live this as data practitioners. Ultimately, we recognize that there is a problem in our ability to fulfill and service those knowledge workers, because we are in a world that that is living with data that's highly fragmented, right? The diversity of data continues to increase, the volume of data continues to increase. And more importantly, even if we have put the effort behind consolidating all the data and the data inputs into some sort of a data lake, we still have the problem where we really don't understand what the data really means. And more importantly, we've put the effort perhaps in creating domain silos. So we have all the data in a specific domain to answer sales questions. We have all the data in a specific domain to answer marketing questions. We have all the data to answer customer service questions. And perhaps the question I want to ask cuts across those domains. And so not knowing the meaning of the data, not understanding the full context of the data and the information, not caring about where the data is stored and how it's structured, becomes a big challenge for companies in this journey. And we all know that AI hinges on knowledge, right? So what does that really translate to? What knowledge? Knowledge of where this data is, what its meaning is, and what its structure is. And so with this knowledge, you have now this challenge of addressing this heterogeneity of the data environments that live inside of large organizations. And so how do you tackle that as an organization? You have, at this stage of the game, most of you who are obviously on this call perhaps have heard of the notion of a knowledge graph. And this is Gartner's slide talking about the impact knowledge graphs are going to have, between now and the next year. And you can see right there in the bullseye, the center of their emerging tech impact radar. Knowledge graphs are going to have a very meaningful impact, especially with respect to the build and data related technologies. Knowledge graphs are the appropriate targets, as they mentioned, to essentially exploit the business value for large language models, because knowledge graphs represent the semantic meaning of the physical and digital worlds. So what does that really mean, semantic meaning? Well, let's take a look. We think about the way we store and structure data. A lot of that data, over the long years of practicing good data hygiene and good database skills, we tend to structure data to be optimized for how it's stored and how it might get queried. And of course, that's fine if you only have one source of information for the entire enterprise, for all your business operations. But we know that this gets replicated, this gets duplicated to the extent that you now create purpose-built applications for different business scenarios and business areas. And each purpose-built application comes with its own mechanism to optimize storage and optimize querying. And that presents a challenge when you have to cut across a lot of those silos to ask those business questions. And so what becomes important with a knowledge graph is the representation of information in the way it needs to be consumed, first and foremost, without regard to where the data lives, how it's structured, and what system it belongs to. So that becomes a critical component of how you model it for information that presents to the user the context of all things that matter for them in order to service up the insight they need. And that is where knowledge graphs really shine, is this representation where you take data that is optimized for storage on the left-hand side to being optimized for consumption and sharing on the right-hand side, right? Representation as these concepts. And of course, what becomes critical when you think about how knowledge graphs can really become a critical component of your underlying data platform is the fact that you are now abstracting away from where the data is stored and how the data is represented to how the data needs to be consumed. So you almost create this, the notion of a logical data model sometimes gets used there, a canonical data model, but ultimately, or even or business domain ontology, right? Whatever your favorite term of choice is, it's essentially an abstracted data model that sits on top of your enterprise data and represents its meaning in the context of the business use case and how it needs to be consumed. So that's number one. Number two is, well, it's all good if it is, if you understand how to model information, but when it comes down to actually connecting to the data and bringing that insight forward, a lot of times companies have to then constantly build complex data pipelines, very brittle, I should say, data pipelines, to consolidate all this data into some yet another repository. Graph databases are famous for that. Certainly people have done the exercise, the effort to move data into a data lake. And the last thing we want to do is now lift that data out of a data lake and put it into yet another graph database. So, ensuring that you don't have to do that every time you have to solve a business challenge or ask a business question is an equally important element of what a knowledge graph can and should deliver, right? How do you, instead of physically copying and moving data, you federate over that enterprise data landscape? And number three, look, we can model information the best way we understand how things connect and how things relate. But oftentimes, some things that we can't see in terms of direct connection kind of get hidden. They get, they get basically get out of our sight. And so the ability for the system like a knowledge graph platform to enhance the network effect of your data, in essence, being able to infer new relationships, identify hidden relationships, make implicit relationships more explicit through the power of inferencing without having to rework your data models, without having to rework your physical storage layers with computed values or pre-computed values perhaps, or looking at ways to change and add transformation pipelines in the process. That is the power that comes along with a knowledge graph, is this power of inferencing. Think about sort of logical reasoning over the data where A equals B, B equals C, so A equals C type of a very simplistic example, but these can be augmented and annotated with business rules that are very specific to a given domain, right? So in the case of supply chain, I might be looking at a concept. I want to define a concept called anomaly. And the idea of an anomaly is if if a particular sensor on a given warehouse or a truck or a vehicle exceeds a certain value, then you can infer that truck, that vehicle, that warehouse has an anomaly, right? So, or, you understand funds in the case of financial services, and you want to understand its exposure to any coastal events, hurricanes, tsunamis. And so the question you may want to ask is, show me funds that might be impacted by coastal cities. But there's no concept of a coastal event or a coastal city. But you do know there are certain mutual funds are sourced through organizations that are based out of California or Florida. And so asking a question, what's my risk exposure to coastal events can allow you to infer the meaning that in this scenario they're inferring the fact that any mutual funds that are belonging to organizations that are part of those states. So again, that power of multiplying and network effect of your data can greatly enhance your visibility and insight as well. So key critical components of a knowledge graph platform from that standpoint. And ultimately, what you're doing is you are creating a data platform that Gartner talks about in the construct of data fabric. There's also a lot of conversations around notion of a data as a product or data mesh. Whichever or some combination of the two you feel architecturally is relevant to what you're trying to deliver inside the enterprise. That's essentially the power of having a knowledge graph that can represent and harmonize all this data, metadata, and business rules in this sort of abstracted business information model or ontology, right? And that representation itself is a data product of sorts. Because when you begin to ask the question, you ask it through that layer. It also something we reference as semantic layer over a lakehouse, semantic layer over a multitude of data sources. Ultimately, your questions and answers are happening through this knowledge layer, and the knowledge layer knows how to communicate with the underlying data sources, right? So you limit data sprawl through this federated access. You enable citizen data users to self-serve, and more importantly, this is all driven off of W3C open standards, so that facilitates reuse and sharing, which is an important tenet to whatever you build. Is the fact that you want to build something that can interoperate across the organization, across partners external to the organization as well. And then tomorrow, if you wanted to change your underlying storage layer from one system to another, or you wanted to change your consumption layer from, Tableau to Power BI, ultimately you are modeling your knowledge is modeled in the semantic layer, in the knowledge graph, along with your annotated business rules. So you don't lose anything, right? There's continuity in the business. You're now just accessing through a different system or storing your data in a different system, and that's okay. Let me see if I could take a quick zoom in here. Questions. So is there examples of using knowledge graphs combined with geospatial data? Absolutely. Those questions can be representative of specific coordinates of certain types of assets. And as long as those assets have those coordinates, then you can actually run geospatial queries on top of that data as well. So a lot of power there in terms of what a knowledge graph can deliver, even in that context. But yeah, good question. Enterprise AI, hinges on knowledge, but what does that mean in the context of AI? Is the fact that we all know at this stage, hopefully everyone knows, that large language models are designed to answer questions whether or not those questions have real answers or not. It's all probability driven. So what that translates to is oftentimes what is referenced in the industry as hallucinations. So the good news is that the foundation you put in place for your data platform bodes well for your effort and energy that you're going to put inside the enterprise to enable AI or even Gen AI to the larger part of the organization that wants to now begin to ask questions of their data in much the same way that they communicate as humans in natural language. And you can again see from Gartner's Emerging Tech Impact Radar, they talk about knowledge graphs as being a critical enabler for Gen AI, and even used in conjunction with large language models, because knowledge graphs deliver trusted and verifiable facts to their outputs. And that's an important element to the value that knowledge graphs provide in that context. And so you can understand and appreciate that whatever foundation is being laid from a data access or data sharing perspective nicely rolls into how you can deliver and extend the value into generative AI. And we know that there are many ways the companies have started to think about bringing Gen AI inside the enterprise, inside the organization. There's a lot of talk about RAG architectures and RAG architectures, with vector databases or frankly, even graph RAGs. What they don't address completely is accuracy and explainability or even business context, right? So you think about LLMs as by themselves hallucinate, vector databases as part of RAG architectures, maybe they hallucinate less. Okay, so they still hallucinate, right? And that is still a problem for those mission critical regulated industries where you just can't afford to get it wrong, right? And that's where knowledge graphs really help, is because they provide the right guardrails, number one, which means that we're not answering any question that you want to ask about the universe. We're here to only answer those questions for which there is real data to support the answer. And understanding the intent of what the human is asking is codified in that semantic data model. And that semantic data model mapped back to your enterprise data allows the system to ensure that you're only answering those questions that have real data behind it. And so with that, you also have full traceability and lineage. And then more importantly, you also provide a larger business and domain context, right? So that becomes an important element of implementing a knowledge graph as part of your generative AI deployment model. And so what that really translates to is enabling ultimately anyone to ask any question about any data and get a timely, accurate, and explainable answer. And that's where the power of knowledge graphs, when combined with the promise that we're seeing with generative AI and in large language models, gives you now the ability to empower your knowledge workers to ask any questions that's relevant to them in their context without worrying about hallucinations, ensuring that the responses they're getting is based on real-time data and that the answers that they're getting are accurate based on real data that's represented in the enterprise and not some made-up information that was generated and created out in the universe. And so ultimately, how it manifests itself, it could be a chatbot, right? It doesn't have to be a chatbot, but that's one of many popular interfaces companies are beginning to deploy inside their enterprises. Every application vendor now has this facility capability. There's no discussion of copilots to help coding assistants as coding assistants for software engineers. Think of Stardog's Voicebox is a data assistant, AI-powered data assistant for the knowledge workers. And so Obviously a lot of discussion here on this topic. I figured I'd take a time to actually bring this to life a little bit with an actual demo. So let's dive right into it. In the meantime, let me see if there are any questions. Let me go switch first, and I'll come back to questions. I promise I'll take a look at those questions if you give me a sec. So let's go, let's dive into it. I'm going to take that knowledge worker scenario I was referencing earlier on supply chain, where, I'm trying to understand. I'm a quality engineer at Good Beer Company, and there has been reports of beer being reported flat at a particular ball field. Who doesn't love good beer? Who doesn't hate flat beer? And it's important as a quality engineer for me to understand the root cause of that particular problem. But then you can imagine that the questions I have probably span across systems, across domains, everything from manufacturing to suppliers, to distributors, to customer-specific applications. But again, as the quality engineer, as a knowledge worker, I really don't care where the data lives. I really don't care how it's structured. I just want to be able to ask a business question and get a business response, right? So it could be that I'm trying to understand that, and so I might start with a question like, find me customers who are supplied by this particular alliance that have submitted more than 2 complaints. And you can see that there are 2 customers that were supplied by this particular supplier who had submitted more than 2 complaints, Wrigley Field and in Indianapolis Motorway. Which distributor distribute to Wrigley Field, Chicago? I do see there's a question that's popping up here. If you don't mind just holding your questions, I'll promise to respond in a minute. We can see that there are 2 distributors that distribute to Wrigley Field, Chicago, Advanced Beverage and Allied Beverages. So I'm gonna ask the question, tell me more about Advanced Beverage. And this way I'm trying to understand who this distributor is, where this information was sourced from. I can see this data was sourced from Microsoft Dynamics. And I see that they have 2 trucks associated with them, namely truck 002, truck 004. I'm going to ask the next question, which truck has an anomaly reported against it? So you can see that from here, okay, I can't find either, but I do know there's some entity that I may want to investigate further. Okay, well, this allows me to go say, let's look at the specific distributor and explore this information a little further. So now I may say, okay, well, I'm exploring this information. And this information can allow me to represent in terms of these connected data points. I see that there's 2 trucks, 002, 004. I can see more information about truck 002, and maybe I want to expand by, what information gets monitored here. I can see that there was a temperature sensor that's being monitored. So I may want to ask a question a little differently and say, okay, which sensor has an output of type anomaly? And again, you can see that what I'm trying to do is look at the data on the left and say, yep, Advanced Beverage is the one. There are sensors that are reported here, but there's nothing specific to here that I can see that they're being reported specific to an anomalous event. Now from here, I may want to trail and ask for more expansion of more, look at specific outputs if I wanted to do that, or I may want to go back and see what my model represents, right? So the big question here is, what's the model representation of this? Okay, let me see. So I see some folks asking questions in the Q&A section and some in the chat. I'm going to try and see if I can answer some of these before I continue on. Can you share more about the KG and in your comment around federated data? Felt like the KG is defined to represent the business context, and there's a layer that accesses knowledge graph and converts that ask to fetch data based on the business context from the underlying federated data sources. Is that the right understanding? That is the right understanding. And I'll actually showcase that here in 1 second. The next question was, can you speak a little about AI versus Gen AI? Yes. I mean, look, Gen AI, generative AI, certainly looking at leveraging large language models, foundational models to generate content, right? Whether the content happens to be text, whether the content happens to be pictures or images, or code. Um, that's the purpose here in the context of Gen AI. Now, I see AI mentioned. I often People often equate that to ML based, AI, where I'm basically building machine learning models and using that to drive some sort of predictions. Right? So predictive causal AI often gets referenced in that context. In the case of manufacturer, I may want to be doing things along the lines of predictive maintenance. When should I anticipate changing a particular part on a jet engine, given its usage and other piece of relevant information. So that to me is more sort of AI, sort of ML driven. Generative AI is actually generating content, generating an answer, generating some sort of an image. Okay, so let's take a little break. So let me show you in the context of federation, what do I really mean, right? So I'll go back here. And I'll come back to more of your questions. Move into our designer product. And in designer, I'll open this semantic model that I've generated. So in this semantic model, I am basically articulating what are the key business concepts and those relationships that I care about. So I talked about customers. I talked about selling points, where you go buy beer as a consumer, you go buy beer at selling points. Selling points are located at a customer. Customers have distributors. Distributors have trucks. Trucks have skids packed onto them. Skids contain finished products. Trucks have sensors on them. So you can kind of see that I am articulating the specific business context, business domain ontology, the business information model that's important to me as the quality SME, in order to frame how I want to see information. What we're doing from here is mapping these business concepts to the specific location where a lot of this data might be serviced from. So you can see in the context of customer, I have Snowflake set up where I'm pulling in Snowflake data, customer information in my Snowflake table. And in the case of my sensor data, which is live sensor IoT events that I'm capturing from these trucks, that I see all the sensor related data. So all the sensor outputs are being generated and created here. So what happens at the time when I ask that question that I ask, which customers, what sensor information, we federate it into those environments. We convert the specific SQL and push that SQL down to Snowflake and push that SQL down to Databricks and get those answers back. So that's the element of federation based on the parts of the specific semantic model that is relevant to answering the question, and then understanding what data maps to those semantic concepts. I'm able to push the specific SQL down to those systems. And I can connect to, a variety of different systems, 150 plus systems in this scenario. Could be Athena, Redshift, BigQuery, right? Salesforce, Synapse, Trino, it really doesn't matter. But in this scenario, I have Databricks and Snowflake set up. What's also interesting and important is that this concept of anomaly is nowhere in my data. And that's where I was referring to this power of inference rule, right? So this notion of inference, where I've described an anomaly as a condition where when a sensor on a truck has a value that exceeds 45°F, then I want to infer that truck has an anomaly and can be classified as such. And so this information here allows me to, on the fly, create a new concept called anomaly and equate and link that up to these other concepts, so that when I ask a question about trucks and sensors and having anomalies, then what I'm doing is basically inferring that if a sensor value exceeds a particular value, in this case of 45 degrees Fahrenheit, then I can infer that this truck has an anomaly, right? Or that distributor has an anomaly. So even though these concepts, truck and distributors, are nowhere linked to that idea or notion of anomaly, I can make that inference through this business rule that gets annotated on my data model here. So again, the power of bringing to life the network effect of your data, the power of representing data through business meaning, and then being able to federate in real time as a question gets asked into your environments to be able to pull the right data back so that you have full visibility and transparency on where you are sourcing this information from to get the answers you seek. So hopefully that reflects, at least for some of you, what this round trip information. And look, this is just the supply chain context. I could have changed this to a different context, maybe more like a financial services one, right? What funds are available from Fidelity and T. Rowe Price. And what's important here to understand is you could have, it's the same system, but can have different context representation for different parts of the enterprise, right? I can again see this data represented, which funds have both Fidelity and T. Rowe Price. I can see those funds. Maybe I want to ask that question about which funds have exposure to California, right? Or we call them California exposed funds. And again, I can see that I have 8 funds here, and then I may want to have funds that are that are only exposed to California. There's 9 of them, and these are the 9 that I can see California tax-free bond, for example. So I've switched context. I switched my user persona, and the guardrails through which I can ask and answer questions are tied back to the semantic model. Now, what I can't do is ask beer questions here in this particular scenario, right? And in the beer scenario, I can't ask questions about mutual funds. So I might be in finance division in one part of the organization. I might be in supply chain, and you can create these guardrails through this business context that can map to specific parts of the data ecosystem that has the data to answer the questions. And again, there's like I said, there's full visibility, interpretation, transparency, and in terms of explainability, what queries were generated in order to answer the question. So you have full track and traceability sitting behind that. So hopefully that was a good segue, just to kind of give you guys a little bit more context. Like I said, sometimes pictures are worth 1,000 words. Let's get back into our slideshow mode here. So how does it all work? Stardog, it basically is the core of Stardog is an enterprise knowledge graph platform. We can absolutely virtualize, federate over your data. We also have a storage layer. So if there's a reason to materialize data, you have that ability to do that in Stardog. If you want to cache, you can always cache it for optimized, better latency needs. Where everything starts in their journeys, if let's say you have your metadata already cataloged with business glossaries defined in one of the popular data catalogs, we can harvest metadata directly from those source systems or directly from the data catalog itself. In fact, we have bidirectional support for Calibra in Microsoft Purview. We integrate with Unity, we integrate with Atlan. So a lot of variety of data catalogs we can connect to, besides the variety of data sources that we can connect to as well. And there's a full security model. The security authentication can be built on top of your security layers. Inside the organization, we have pass-through authentication, so we can authenticate based on the source system if need be. There's fine-grained security down to what parts of the model you may want to share or not share with a particular user. Maybe their social security number, PII information. And then the compute layer, everything you would imagine, from the query engine to the vector search to inferencing, all built into the platform. Access not only through the Voicebox interface, but you can also access the data out of the knowledge graph directly into your SQL-based BI tools. Your Tableaus or Power BI. We have a MySQL wire protocol we implement on top of Stardog. You can also embed that directly in as a Python data frame inside of your notebook. So if your data science community wants to interact with it, they can interact with it as well. And flexibility both in terms of where it gets deployed, what cloud environment gets deployed, and how it gets deployed from a Kubernetes perspective. There are industry knowledge kits for those that are looking to get a jump start. Manufacturing, life sciences, financial services tend to be our most popular industries. There are certainly industry ontologies out there in the public sphere that you can leverage as the starting point to your model. We also have the ability for you to construct the semantic model based on the underlying metadata that we harvest. You can also use the power of Voicebox. So in my previous example here, we have the ability to use Voicebox as more of an assistant. So maybe I want to say, add description to the concept warehouse. And again, this assistant allows you to facilitate sort of this, and you can see that it took the warehouse concept in my model and added an English text description of that directly here. So more of a facilitator, helps you as the persona that might be the data modeler or that's designing these semantic models to leverage some of the power of Voicebox that comes along with our system here. Back here. As well as the exploration, I kind of showed you a bit of that, and then there's an IDE for more power users built in here as well. I showed you the modeling, leveraging the power of Voicebox and our Gen AI capabilities to facilitate modeling, but also the querying component. So the query generation is really at the heart of what we provide by leveraging the large language models, which is why and how we eliminate any hallucinations. So we're not relying on the large language model to generate the answer. We're relying on the large language model to generate the query for Stardog, which then gets executed against your enterprise data in that federated data manner that I mentioned earlier. And sitting behind all of that is sort of this agentic chain within Voicebox, where we have multi-agents running from the time a user gets to ask a question to the chat history. Do we see if this is a question we've answered, to interpreting the question, identifying specific terms, to identifying the parts of the schema that are relevant to answering the question, to generating the query, to validating the query that gets generated, to executing the query, summarizing the result, and validating the result to make sure there are no hallucinations. And that is what gets then sent as an output back to the user. So again, an agentic architecture, multi-agent architecture sitting behind our Stardog platform. And really the industry talks a lot about RAG and graph RAG. We call it safety RAG. It is unique in that sense that we're not the last answer. And the answer does not come from a large language model. The large language model does not generate the answer. In our scenario, the large language model that we're leveraging in this particular scenario is to generate the query. And then we validate the query, and then we execute the query to see what data is available in your enterprise. And if that data is available, is when we actually provide a response. What you get with Stardog is a fully integrated software and hardware stack that reduces your sort of time to development and enables your business users to impact quickly. It provides a modern foundation for your data platform by harmonizing and federating over your enterprise data and metadata silos, whether they are structured or semi-structured, encapsulates that domain-centric knowledge that can be represented as those semantic models or ontologies, which helps also provide the right guardrails and enables that contextual relevant question and answering that I just walked you through. More importantly, it provides for data security and privacy and better unit economics because it's all built into this fine-tuned open source large language model that we leverage versus OpenAI based offerings or where you have to pay by token, number of input tokens per second. Those are not scalable financially in large enterprises as a model. And of course, they have a tendency ultimately of generating hallucinations. And because we don't rely on the large language model to generate the answer, we are absolutely hallucination free in our approach that I'm representing here. If you are keen on getting started and experiencing this for yourself, we have some starter models for you to kind of play with for free. If you want to have a small data set or sample data set that you want to try to drive a small POC with, we have a very nominal offering as well, $39 per user per month. And then we have, of course, we support an enterprise model if there is ever a need to scale at that level. So with that, I'm gonna stop sharing. I'm gonna quickly look at the questions. I also know that there was a offer on the table for a specific winner to be chosen based on who is attending. But let me first take your questions at this stage. If knowledge hasn't been documented or it's a bit unstructured, is there a way to efficiently virtualize the data into the knowledge graph? More importantly, for the long term, is there a way to efficiently materialize all data into graphs, not just the data models? Yes, absolutely. Like I mentioned earlier, there is ability for me to do that. There is a materialization layer in Stardog, and the same thing that gets modeled in Designer and starts off perhaps as a virtualized set of connections can, through a very easy process, get all of that information materialized, either in a caching layer or directly in a materialized storage layer within inside of Stardog. And again, because not everything is nicely documented, as you mentioned, sometimes you have data that's well documented in a business glossary, in a data catalog somewhere. That's great. We want to leverage that. But you don't have to have a data catalog. You don't have to have a business glossary. We can start connecting directly into your source data, pull whatever metadata is available and accessible to us in that manner at that point. And that can be your starting point, right? So obviously, your data landscape might be very large. You don't want to boil the ocean. You want to start with a few data sources that are pertinent, starting point to answering the business questions. So you always want to start with the end game in mind. What are the business questions? Who are the knowledge workers? And then kind of back into what are the specific concepts, and then where does that data live? Is your cache across silos in a federated, harmonized into cohesive database relationship graphs? Yes, the underlying harmonization is in what's called an RDF construct. For those that follow semantic web constructs, resource description framework is how a lot of that data gets harmonized in that manner internally inside of Stardog. What database do you use? Is this a lakehouse or some sort of graph database? It is a graph database, like I said, the RDF construct when it comes to materialization. So it is inside of the Stardog platform itself from a materialization standpoint. Can you speak to the query validation? How do you measure when there are issues with inaccurate queries? Well, look, that's a big part of our, I call it a secret sauce. We know our query language, which is it's an open standard language, right? Sparkle. So there's the component there that allows us to validate query when on construction. We understand what part of the query was invalid. Even before the Gen AI component, if someone handcrafted the query, we can tell them, what part of the query has a specific validation error. So we use the same mechanisms to help inform the LLM to say, oh, look, this part of the query is not properly defined. Can you correct that? And so that's built into the agent architecture that we discussed earlier. We do support JSON LD. Good question there. How Stardog is correlated or related with Snowflake? Much the same manner. It's related to any source of information or data. We are typically a layer that's like a semantic data layer or knowledge graph that sits on top of your source data. That could be Snowflake, that could be Databricks. It really doesn't matter. it's ultimately independent of the source of the data itself, right? So structured, semi-structured, Snowflake, BigQuery, Databricks really doesn't matter. We say that we are like a semantic layer. Almost, we talked about this notion of conceptual data model or a conceptual model or a business domain ontology that sits on top of your enterprise data, regardless of where it lives. Are you using Cambridge Semantics for materialized RDFDB? No, we're not. We are Stardog. Stardog is a homegrown system based on open standards, pretty prevalent in the industry, and in some regards, very comparable, perhaps, but very different to what Cambridge Semantics provides. Importance of ontology that accurately represents the business versus the ERP's based data, that is ER based data. I assume that's what you meant. Discuss the importance. Yes, absolutely, right? So that's the beauty of having an ontology layer that represents the business. So you don't really need to think about how you construct the data from a storage or query optimization standpoint in terms of the underlying source of the information, because there's could be multiple source systems that reflect that. What you want to be able to do is construct this ontology that is a mirror image and a representation of how the business views these concepts, right? Oh, you said ERP like SAP, not ERD. Okay, so it was not a mistype. Thank you, Ray. Yeah, absolutely, right. So look, ERP's base data is very generalized, and ERP is one of many systems, right? So you have to certainly look at, and what happens oftentimes is companies will make the effort to pull data from an ERP and put it into a data lake somewhere. You lose the business context there anyways. ERPs are also very limited in terms of how complex they can represent multiple hierarchies. So the complexity in the relationships and hierarchies are not well designed or represented in ERP. So that's another reason why an ontology is a great way for you to capture sort of that real world business domain modeling purpose of capturing these complexity in those relationship and hierarchies, right? So in relational terms, we represent everything as one-to-one, one-to-many, three-part normal form. But in the real world, we know that relationships are many-to-many, and that complexity is best represented in the ontology that is the semantic model to the knowledge graph. Our performance absolutely outscales Onzo any day. Number one, because the power of virtualization, there's less reliance, on materializing a lot of that data to put in memory. Secondly, the hardware requirements, and we have published benchmarks for these. We run BSBM benchmarks. Happy to share that with you, Joseph, if you want to ping me on the side. Our requirements for hardware, we run on commodity hardware. Onzo runs on very expensive hardware in order to process data and give you the performance that it does. How do I map an already existing relational database to an ontology? Do I have to materialize data each time? No, absolutely not, right? That's the whole point, is that the mapping that I showed you earlier to Snowflake and to Databricks allows you to only map the metadata, technical metadata in those tables to the business concept attributes in the semantic model. We help facilitate that modeling for you. We help facilitate that mapping for you. And then on execution, we push query down into those systems. So you don't have to, we push down into your relational database. We query that database to get the answer. So you don't have to materialize data at all if you don't want to. You have the option to materialize. And that really depends on the type of source you are connecting to, and depends on other scenarios of the business use case and latency and other things. So great, all good questions. I'll kind of flip over to the chat here. Can this platform leverage a data catalog such as Elation? Absolutely. As I mentioned, Joe, we have connectivity to pretty much all the popular data catalogs. So it's definitely Elation is one that wouldn't be a far fetch for us to connect to, given we built these bidirectional integrations with a lot of the popular ones like Calibra and Purview and Atlan and Unity and others. So Let's see. I believe we have a winner. So let me take a quick break to announce the winner for the $100 Amazon gift card for attending today's webinar. That's John from Electronic Arts. John, congratulations. Just meet on our marketing team. We'll reach out to you shortly after this session, and we'll send that gift card along the way. I'll take a couple quick questions. FIBO for financial services. I have a personal I have a personal point of view on FIBO. It certainly is holistic in terms of what they cover. Sometimes can be very complex in terms of what a client wants to do with it. Yes, you can start with FIBO. It's a great starting point, and so making sure that you only use parts of FIBO that are relevant to you. Otherwise, it'll be a bear of an ontology to deal with and work with. Property graphs or RDFs. I'm biased. I think it's already well known that RDFs, number one, open standards. B, that distinction between property graphs and RDFs are just no longer relevant. And certainly RDFs with the ontology layer give you that abstraction of the schema or the data model that property graphs don't, and so are well represented to an enterprise data fabric or data mesh type deployment architecture. Okay, I think, tell me more about ER data. Would you tell me more ER data? I'm not sure what I can tell you, Manish, but if you ping me on the side, happy to answer those questions. Appreciate all the questions, appreciate your time, appreciate everyone's attention, and hope you found this beneficial and useful. Thanks for attending, and we'll let you guys get back to your day jobs. Appreciate it. Thank you.